Hi, this is Margo. This is Monday afternoon, January the 13th, 2020, and we're going to do our weekly update today. We're going to look at methane data from NOAA because CAMS does not have any methane data up. We're going to talk about that. We'll look at the chart, and it has gone up a little bit this week according to the NOAA readings. And we're going to focus on sulfur dioxide today, and I've got a couple of articles that I'm going to bring you, and we're going to look at Climate Reanalyzer, and NASA Worldview, and Volcano Discovery. Look at all this sulfur dioxide coming out of the tall volcano, and talk about what's going on in the Antarctic as far as sulfur dioxide and possible plate movement, because I'm seeing some stuff going on down there. So sit tight, and I hope everyone is doing well. We're going to have a jam-packed show. I'll be right back. Alright, first of all, we're on CAMS, Copernicus Atmosphere Monitoring Services. And if you've been following me for a while, this is where I like to track methane. And right after I did the show last Monday, the latest data they had up for methane was from December 31st. And right after I did the show, it went down. And there's no methane data. And it's 12/31/19 is the last date and time that they have, and it's not up. There's also no carbon dioxide data. Carbon dioxide runs along with methane as far as not being updated as much as the other greenhouse gases. I did open a support ticket in CAMS on Thursday, I believe. Yep, Thursday. And I got a quick response, and they said they were aware of the situation, that they had become aware of the situation the day before, and that they were working on it. So that was Thursday, and here we are Monday. So the last time that it was down a long time, and then I opened a support ticket to bring it to their attention. They changed all the color ledgers in CAMS, and it was, so I don't know what they're doing this time. I have no clue. So we're going to muddle along the best we can. We have plenty of other stuff to look at, and I really like studying sulfur dioxide. I think we can learn a lot about what's going on with the earth and the atmosphere from sulfur dioxide. And usually wherever we see releases of sulfur dioxide, we see pretty good sized releases of methane as well. So you can just assume that wherever you see cream colored and higher, that would be high methane readings as well. So we're going to start. I've been watching this area down here in the Antarctic for the last week or so, but before we go there, we need our attention is drawn to this big release over here. This is from the Taal volcano in the Philippines, and it's still erupting. So the best view to get on that is from Southeast Asia and Indonesia. It's right here. And the volcano is on one of these northern islands up here, not very far from Manila. And this is from today. This is where it exploded. If we look back to yesterday, it showed release. It was some releasing up here. And if we run the movie, the big release, we can see it building up until the end of Sunday. We can see it still kind of building reddish here, and then when we go to the new day, that's immediately we see the big release. So it's still releasing and it's still exploding. They don't know how long it's going to keep on going. I've got Volcano Discovery pulled up with information about this volcano. We can see some pictures. It's still erupting. Here's continuing lava fountains, and new vents were observed. So these fountains are it's making new vents. They've had a lot of lightning going up into the clouds. Here's a satellite view from the 13th. Here's a picture of the explosion. And it's a small volcano. It's not that big. Here's a picture of the lightning. And this is its first eruption since 1977. And if you want to see you want to see on Google Earth where it is, we can do that. I meant to have that open, I forgot. They had to evacuate a bunch of people, and there are no flights or anything going out now. We'll just spin around here. It's up here. Here's the Philippines. It's on Luzon, which is this northern area. Here's Manila, and it's to the south of Manila, and then it's in the middle of a lake. This is the lake. It's green colored, but it's called Taal Lake. And then this is the volcano, and this is the crater. So this is what's blowing up. If we do 3D, we can see it's not very big. So I guess they weren't expecting it to blow up, since nothing had really happened since 1977. And looks like there was water inside the crater as well. So when that exploded, if there was water in there, then that would, mixed with the ash and everything else, that would be really deadly. And there have been landslides and different things. Let's turn it back around. Go back to 2D. Now on the earthquake map, I'll show you what it looks like. And they haven't had any earthquakes since this has been going off up here. Okay, here's Manila. It's right down here. Here's Lake Taal, and it's in the middle of that lake, like I showed on Google Earth. And there it looks like, according to the earthquake map, there is water in the middle of the crater. So I think that's pretty unusual. It just depends on the kind of volcano. So let's hop back over to This is Volcano Discovery. Here's all their reporting. Here is from March 29th, 2019. They said the volcano is becoming more restless and is showing signs of a possible reawakening. So that was back in March, about 9 months ago. And then here's the 12th, where it first started erupting. Can't really see anything of the ash on NASA Worldview right now. I tried looking. Now here's where, here was their report. This is from the 12th, yesterday. Ta'al is erupting for the first time since 1977 and has sent steam and ash plume to 16.8 kilometers or 55,000 feet. That's really high. That's really high. Accompanied by a lot of lightning. 5 volts has raised the alert level to 4 on a scale of 0 to 5. And we can read more there. It's an extremely dangerous volcano that has the potential to produce massive base surges and tsunami waves in the lake, as in the last major eruption in 1965. There was a 14-kilometer exclusion zone around the main crater in place. That's what it looks like when it blows up. So it could be dormant for a long time, and then all of a sudden when it builds up, when it gets ready to go, it just goes. Here's volcanic ash advisory reports, several of these. And here's the picture from it exploding. This is an eruption from today, the 13th. Here's an ash cloud captured in satellite imagery. Magmatic eruptions. On January 12th at 1 o'clock or 1300 local time, and today on January 13th between 2:49 and 4:28 local time. So it was in the middle of the night. How'd they get that picture? If that that was from yesterday. That was in the afternoon. It was I was going to say in the middle of the night. You wouldn't see blue sky. Here's another report from today. Explosive activity continues. Tokyo warned, this is the Volcanic Ash Advisory Center from Tokyo, warned about a volcanic ash plume that rose up to estimated 36,000 feet or 11,000 meters. Here's another report. 5 Oaks recorded that the activity of the volcano continues with lava fountaining. Lava fountains on the north flank remain active, currently about 500 meters long, and new vents were observed. Steam plumes rose 2 kilometers above the summit. The volcanic ash is dispersed towards the southwest. Since January 12th at 1300 local time, The seismic station records 144 volcano tectonic earthquakes, of which 44 earthquakes were felt in area of Tagaytay, Alitagtag, Limerine, Santo Tomas, Talisay, and Batangas. Increased seismic activity is accompanied by magma movement under the volcano, which may lead to next eruptive activity. Well, okay, so I was wrong about the earthquakes. We're just not seeing the ones that USGS picks up. I think they have to be like 4.5, or around 4 and higher to be international to register. So those must be smaller earthquakes. Here's the latest Volcanic Ash Advisory Center. There was an eruption, and FL040 extended southwest reported at 1:13 on 2020 and 2002 Zulu time. So it's still erupting. So I don't know how long that's going to go on. Here's some more pictures. Lava fountain from Taal main crater. I want to see that. Look at that. That's a lava fountain. That's where it's exploding up into the air, like a water fountain going up. It's a lava fountain. I wouldn't want to be there. So we're going to keep all those people in our prayers. Now, let's get back to our sulfur. So this is what sulfur dioxide looks like from there. I was curious if we could see anything at surface level. There's not very much. Usually when it's a quick release, we won't see much at surface level. We'll see it usually here. We can see some at 850 HPA. Here is at 500 HPA. There's the huge release. So it shot up to 500 HPA. That's about 18,000 feet that you're going to see immediately. Let's see what it looks like at 300. There's not much at 300. We're going higher in the atmosphere as the numbers get smaller. Nothing at 50. But here it is at total column where they add it all up through the layers. So we're going to keep an eye on this. While we're on sulfur dioxide, let's go to the Antarctic now. Well, we can also see where, like I said, wherever it's cream colored, this is 2 parts per million. Gold, the light gold is 5, darker gold is 10. When we get into the gold orange, it's 20, red orange is 50, and this dark red is between about 70 and 999 parts per million. So we've been seeing a lot of release over here in the Kazakhstan area for a while now. I still can't figure out what's releasing there. We also see high releases here in China. This is from industrial activity. Here's Popocatépetl. This is constantly releasing. This is just to kind of put things in perspective. And we have volcanoes going off the coast of South America. There's one down here in South Africa. Here's Hawaii that's always releasing. We're always seeing sulfur dioxide release up here in Alaska with different volcanoes and lots of earthquakes. We also are seeing, and I need to do some more research on this, when we go to um, 500 HPA. Wait, let's go to 850. When we go to 850, this is just above the surface level, just above 1,000. So it's 850. We're seeing high releases. This is in the Denver area, Denver, Colorado area. I'm not sure why that is. And this is similar to, here's the Kazakhstan and this whole region. And look at here in China, also here in Saudi Arabia. Here's Popocatépetl in Mexico. Here's Africa. So, and here's the Taal in the Philippines. So we're seeing it can be volcanic in nature. I'm thinking that it can also be from rocket testing and things that are launched that we're not aware of. And in the Denver area is Colorado Springs, is south of Denver. We also have Martin Marietta or Lockheed Martin in Denver, in Littleton, which is a suburb in southwest Denver. And over here in Kazakhstan, they have a cosmodrome that Russia uses. It's not right there. It's over to the west, but I'm thinking there might be other things. So, just a theory. I posted a video about my preliminary sulfur dioxide findings. I posted a couple of videos about these weird sulfur dioxide, especially Kazakhstan. I've been looking at this, and then this last week I posted some about the sulfur dioxide coming up in the Antarctic. So we're going to look at that now. So we're going to go back to Thursday. We're going to go to, first of all, I'll show you the South Pole view. Now to be oriented, this is South America. Here's the tippy point. This is here's Australia over here. And see, even from the New Zealand the Australian wildfires, it's not red. It was red with sulfur dioxide, but it's not anymore. In fact, there's more higher levels of sulfur dioxide coming up from New Zealand than from Australia right now. So here's the Antarctic. Here's the West Peninsula. Here's North, South, and East. We're seeing, so we're looking for cream colored and higher. We have it over here on the east side. Also, it's been coming up here before Thursday. I'll show you what was coming up. I have these saved. Let's flip back. Let's flip back to total column. Here's what it looks like on Thursday. And we are seeing a release from this western peninsula, this area, and coming out across. This is the Atlantic here. This is Africa here. So this is the Atlantic. Over here is the Pacific. Over here is the Indian Ocean. So if we flip it to see the Antarctic, now this is how we're used to seeing it from NASA Worldview. Here's north, south, east, and west. So I'd like to go back and show you. Here it is from the 7th, which was Tuesday. This is when I first started noticing this release here. This is total column. This is from Tuesday. We're also seeing high releases over here on this western side. I have an article talking about the ice melting more and things heating up on this west side of the Antarctic that I'm going to share today as well. Here's from Wednesday. We're seeing more release and seeing it spreading out to the north. This is the Weddell Sea here. Here's Thursday. So that's the oldest data that's on cams now. Now I want to show you something. I did a video about this for my Subscribe Star members, and I'm going to play just a little bit of the video. I've got the volume turned off. So here it is from Tuesday. You can see down here, here's from Wednesday, Tuesday. This is the 500 HPA level. And so, since there's so much sulfur dioxide at 500 HPA, it shows a release, a quick release that goes pretty good, about halfway up in the atmosphere there. And so it makes me think there's some kind of underwater, either volcano activity going on or maybe earthquake. Sometimes the sulfur dioxide release can be a precursor to earthquakes. We saw some earthquakes here. Go ahead and play a little of this. I do have the volume off right now. Has to wake up. There it goes. Here I'm showing that. And it wasn't there before Tuesday. There was nothing, no releases there on Tuesday. It started Tuesday. But like I said, so let's go back. So here's Tuesday, like you saw in the movie there. This is total column. You saw the 850 HPA in the movie. So that signifies that it's a quick release. and goes up higher into the atmosphere. Here it is from Wednesday, total column, and here it is from Thursday. So let's move on back over to cams, and let's look at 500. So this is Thursday. Still good amount, and it's streaming out across. Now there's a tectonic plate line that runs along here, the Antarctic to the Atlantic. I'll show you that. It's right here. So this is the area that we're seeing. Let's go to all magnitudes. This is the area. Here's the little western point of the peninsula, and then the sulfur dioxide is spreading out. And then this area has had quite a few earthquakes this week. So let's look at 7 days all magnitudes. In fact, as soon as I did that video on Tuesday, there was an earthquake that came up on the 7th, a 4.9 happened on the 7th at 6:27 p.m. That was Pacific time, my time. So it was right after I did the video. Then there was another earthquake right next to it of 4.4 on the 8th. And then a 5.4 on the 9th. So I'm thinking that this is showing some plate movement. And then there were two more further out, and then another one over here. What I'm looking at is anything around this red line, this bottom red line. So that could denote, I think it's plate movement. Frankly, I think that's what we're seeing, and this is the forerunner of it. Was all the sulfur dioxide coming up. So there's Thursday. Let's look at Friday. Yep, see, there's a new, that's like a new little area. And then it's streaming out. Let's look at Saturday. Here's where it's going over. And sulfur dioxide is heavy, and it hangs around in the atmosphere longer. And here it is today. There it is today. It's kind of dispersing now. I also like to look at the South Pole view, even though I have to rearrange it in my mind, because we can see, get an idea of where those tectonic plates are. So here it is today. Now here we're seeing pretty good size release down here off the Ross Sea. Let's go back to Thursday. Go back to the beginning here. Now when you run the forecast for sulfur dioxide, it's not really accurate past the first day. The first day is the actual data, and then they have forecasts. It's not that accurate because the volcanoes can explode. The earthquakes can happen instantly. They can't really. That's not part of the model. So here it is. Let's look at surface. See, not that much surface level here. Where you do see surface level, those are where the volcanoes are. Here's 850. That's this volcano down in South Africa that no one talks about. Here's New Zealand. Here's 500. That's the level I like to look at to see what came up quickly. And it's definite, you can see it's definite that came up quickly and spread out. And here's our tectonic plate around there. See? So, let's look at Friday. We'll leave it at 500. So here's a new release here. Now look down here in Australia. That's from the fires. 500. That's in southwest Australia. Here's Sunday. Oh, and this right here, that's where that high level of air is over in the South Pacific. The blob, that's where the blob is. So it's kind of spreading out by today there. So I'm going to leave that now. I know I took some time on that, but I think it's interesting as we want to understand what's going on. I mean, there's so much more than just methane to report on. And speaking of that, here's an article. West Antarctica melts from below by geothermal heat and from above via changing wind patterns. Well, it's other stuff too. This is from Strange Sounds. Futurology. Not sure when this was. I think it's recent. A lot of people are reporting on this. They're showing what Antarctica looks like under the ice, and that there are lakes and rivers and stuff. I've shown this before. 2 new research studies confirm that geothermal heat flow is the dominant cause of West Antarctic ice sheet. Meanwhile, another study says West Antarctic ice loss is influenced by internal climate variability. Let's get a clean view of this. There's a map of the flowing water under the Antarctic ice sheet. The blue dots indicate lakes, and the lines show rivers. Marie Byrd Land is part of the bulging elbow leading to the Antarctic Peninsula. Left center. Right here. Well, this is the Ross Ice Shelf here in Ross Sea. Here's the peninsula. Right over here is the Pine Island Glacier. So what we were looking at with the sulfur dioxide release was right here, up here on this tippy point. They've had quite a bit of releasing down here and over on here, this side as well. So, and I've shown that they found over 100 volcanoes under the Antarctic. So, you know, I think those are coming back to life and making everything melt. In addition, okay, when we look at NASA Worldview, here it is from today. Let's refresh so we get the latest data. Okay, it's all in for today. Plus, they're doing the beaming, and that heats things up. So here's the tippy point that we were looking at. So the sulfur dioxide release was right over here. And remember what we're watching? Here's this iceberg A68. And look how much it has moved since my last video. And it's free of the ice. This is clouds. These are all clouds. It is free of the ice. Nothing is holding it in now, and it's ready to go out to sea. But when you zoom in, you can see evidence of beaming through the clouds. And so that's heating things up. Look at all of this. This is not natural. This is not natural. Look at that. Look at this. So last week, so a week ago, was January the 6th. So if we go back to the 6th, see the iceberg was way down here. Here's the 7th. It moved quite a bit from the 6th to the 7th. There's a really good view of it. And it's kind of breaking up here. That's the 11th. It's the 12th. And here it is today. But this used to be out. It's more jagged and in. So it's melting and breaking up a little bit right there on that side. So they're mainly talking about this west side. It's melting all over Antarctica. Marie Byrd Land is down here. That's what they were pointing to. Here's the Ross ice sheet. Now over here is the Pine Island Glacier. We're looking through a bunch of clouds right now. It's still chipping off. Let's go back. Here's a good view. These ice pieces they've been coming off. This is getting ready to calve. I showed this last time. This line, it's this big long crack coming across. So that's getting ready to calve off. Now I don't know if that's going to calve before the end of their summer season or not. So that's kind of what I'm watching. And then over here on this east side, this is the Amory ice shelf and that A28 that broke off. It's too cloudy to see. It's up here, but it's getting ready to move out too. Alright, now let's move on to some methane. I took the NOAA readings from Saturday the 11th for the 477 millibar. That's the reading on the small GIF that you click on the NOAA website. Then it says 469, so I guess it's 469, but it's 477 on the other GIF. So this is from Saturday the 11th, the morning reading for the Met-1 satellite. The mean was 1875. The range is 1460 to 2687 parts per billion. That's very high. Very, very high. And so the 2000 to 2687 is in this fuchsia color. We can see all around in the northern hemisphere here, and also down here in the South Pacific, where we were seeing the high sulfur dioxide, where the blob is. And this big white thing is missing data. That's missing data. Also, the gray is no data for whatever reason. Here's the Met-1 satellite for the afternoon of Saturday. The mean is 1876. The range is 1403 to 2348. So that's a big difference. We're still seeing the high readings down here in the South Pacific area as well, and also throughout the northern hemisphere. The Met-2 satellite for the morning of Saturday, the mean was 1858, and the range is 1481 to 2465. That's high. And here it is, the afternoon reading. The mean was 1858, and the range is 1430 to 2300. And we're seeing the chartreuse down here again. So we plug this into the spreadsheet and the chart. Here it is from the 11th, and added them up and divided by 4, and it comes up to an average for this level for 1866.75 parts per billion. So that's showing that it's up by 0.75 parts per billion since last week. And last week it went in, so in my report last Monday, the week before, through the 4th, it had gone up 4.25 parts per billion. So it's still going up. So did we hit the lowest? I don't know. We might have hit the lowest that we're going to hit for this winter season. We'll see. But there's that, and it's still 9.5 parts per billion higher than where we started on March the 1st. So there's the methane. I also have an article that I want to share with you concerning methane. This was sent to me by Rosemary Hill. I'd like to thank Rosemary for this. This is from the European Space Agency, and it's called Methane Leak Visible from Space. And this is a review of a paper that was published in December. And it says, data from the Copernicus Sentinel 5P satellite revealed that an explosion in a natural gas well in Ohio in February of 2018, so it's 2 years ago, released more than 50,000 tons of methane into the atmosphere. The blowout leaked more of this potent greenhouse gas in 20 days than the majority of many European nations do in a year from their oil and gas industries. Now, first of all, my first comment is it would be nice if we would hear about something like this before 2 years has gone by so that we can track it. Now, I don't know what this would look like on cams. Here's where it happened, this black dot, and here's where the methane went up around there. So where did this happen? In Ohio. And so here they're showing the methane high over here in Pennsylvania. So, methane is very light and it moves around pretty fast. Now, I first became aware of cams in early 2018, and I did my first methane video in April of 2018. So this happened before I was even looking at cams or even knew how to look at methane and kind of how to interpret it and stuff. I mean, I'd like if something would happen like this now, I'd like to see what it would look like. Anyway, moving on. The findings were published in a study yesterday, and this is from December. I think this was December 2017, December 17th, 2019. Okay. In the Proceedings of the National Academy of Sciences. If you want to see the whole paper, it's not the whole paper, but you can see part of the paper, the review, right there. And the study reveals the importance of using satellite data to detect and quantify pollutants such as methane. Data from the Copernicus Sentinel 5P's Tropomi instrument revealed that 120 tons of methane were emitted per hour due to the blowout. The location of the explosion is marked by a black dot in the image, right there and right there, and shows the methane emissions before and after the blowout. The black arrow indicates the wind direction and the direction of the methane plume. So it blew up here, and then the wind blew it to the northeast. Klaus Zainer, ESA's Copernicus Sentinel 5P mission manager, comments, "These Sentinel 5P measurements show that satellites can measure the concentrations of greenhouse gases emitted by a point source. The satellite's capabilities will be further exploited with the upcoming Copernicus carbon dioxide monitoring mission. While carbon dioxide is more abundant in the atmosphere and therefore more commonly associated with global warming, methane is about 30 times more potent as a heat-trapping gas. It usually enters the atmosphere mainly from the fossil fuel industry, landfill sites, livestock farming, rice agriculture, and wetlands, but can also be released during oil and gas extraction." And I can add that it can be released from earthquakes and from melting permafrost and other things too. And from the permafrost melting under the water. Sentinel 5P with its state-of-the-art instrument Tropomi can also map other pollutants such as nitrogen dioxide, carbon monoxide, sulfur dioxide, and aerosols, all of which affect the air we breathe and our climate. Yes, we knew that. So thank you, Rosemary, for sending us that. So we've covered what we can on methane, and we've covered sulfur dioxide, we've covered the volcano. Let's look at CO2. Here's the latest CO2. Let me refresh. Okay, January 11th. This is at the Mauna Loa Observatory. It's 413.15 parts per million. And January 12th of 2019. So this was 2020, because I said 2019 accidentally. So last year, this time last year was 413.45. So that's a little lower. But December was higher. December 2019 was the highest, was 411.85, and for 2018 it was 409.23. So we saw a rise there. You can also click on NOAA, and you can see that for the last few days. See, on January the 10th, it was 413.54. So it can go up and down pretty quick. This is at the Mauna Loa Observatory. So there's that. We'll hop back over to NASA Worldview, and if you want to see how they block out data, there's how they block out their data. It just is not there. So if we want to look at what's going on with the wildfires, there's still smoke down here. Let's turn on our fires layer. See, lots of fires still going. Here's some down on Tasmania. And over here, this is where we saw the sulfur dioxide releasing from this area. Now Perth is over here. And this is devastating. I don't think Australia is going to come back from this. I don't see how. It's just devastating what has happened. It's just a wasteland where these fires have been burning out of control for months, literally. So if we go back, I want to show something. Look over here. The smoke, and this is where where the blob is. Let's go back a few days. Alright, here it is on the 3rd. And see how the smoke had come over and got caught up in the jet stream, or the wind here. Now watch. Here's some new smoke coming across. Here's this big smoke coming across. Remember this picture. Look at this. Here it moves on up north of New Zealand and across. Here it's like it's got its own blob. It's turned to its own blob. That's on the 7th. Here it's just a kind of a circle thing on the 8th. And it's kind of spreading out here on the 9th. Now it's being caught up in the wind. There's the 10th. Here it is on the 11th. 12th, and here it is on the 13th. So if we compare this, let's look at Climate Reanalyzer. Let's look at the 2-meter temperature anomaly. Let's go over here. Let's look at sea surface. It's down here in the South Pacific is where we're seeing that so brown. Let's just go ahead and click around. Okay, see? It's this whole area to the east of New Zealand where the sea surface temperature, that's where the blob, it was kind of isolated, but now it looks like it's spreading out. But it's also affecting the air. And I think the smoke and the sea surface temperature being so high is causing this to kind of hang around, the smoke to kind of hang around and not really disperse. So I just found that kind of interesting. Here's our 2-meter temperature anomalies. It's red over the Arctic. I really would love to see the CAMS methane data. I'm sure there's methane coming up through the sea ice. And now, remember how it was so red all across Russia and Siberia? It's still red over here, over northern Russia, but it's not quite as red, but it's still brown over Siberia, and brown coming from the Chukchi Sea across and Laptev Sea. And then here, North America, we've got extreme cold air coming down over Canada, and then extreme warm over here on the east side of the United States. And this extreme warm over the Arctic is actually just north of Alaska in the Chukchi Sea in the Bering Strait. And then the Antarctic is pretty much brown. So here's how it adds up. For the world, it's up 0.7 degrees Celsius as of today. Northern Hemisphere is 1 degree higher. The Arctic is 2.8 degrees higher. The tropics are 0.5 degrees higher. Southern Hemisphere 0.3, and the Antarctic is 1.6 degrees higher. So that's the air temperature. Here's precipitation. We can see that it's snowing over a lot of the Arctic. And we've got rain coming up from the North Atlantic, and then snow here off the coast of Norway. Here's Iceland. There's snow around there and rain here. And it's snowing around Greenland. And look down here. It never did the rain. I saw rain off the coast of this Victoria area in Australia, and it never came over. It never did. Never got any rain over there where the fires are burning so bad. Let's look at the jet stream. Here it's split and split definitely major split in the northern hemisphere. And look how it goes. I can't tell if this is supposed to be southern hemisphere or northern hemisphere. I guess this is northern hemisphere jet stream that goes so far south. I've never seen that before, where it goes so far south across Africa and India. That's crazy. I guess that's the northern jet stream. It's split. See that? And then here's southern hemisphere, like snakes. That's crazy. Here's the sea ice. We're not doing a sea ice report today. We'll do that next time. In the winter time, I like to just report on the sea ice about every 2 weeks. And we saw the sea surface temperature anomaly. And here it is on the world. Here's the North Pacific. It's even almost getting up into the red. Here's the South Pacific. Here's South Atlantic. That's not looking good. Here's the Indian Ocean. And look down here by Madagascar. And then all around Australia is brown. And then brown to the east of New Zealand. And it's also brown in the areas that we were seeing that sulfur dioxide coming up. So worldwide, sea surface temperature is up 0.3 degrees Celsius. Northern hemisphere is up 0.4. North Atlantic is up 0.3. Equatorial Pacific is up 0.2. Southern hemisphere is up 0.3. And the northern hemisphere, North Pacific is up 0.4. And that's for yesterday. And last but not least, we'll just take a peek at some of these earthquakes that have been going on this week. I've already got all magnitudes for the last 7 days pulled up. Last 24 hours we're seeing 235 worldwide. Seeing some big, here's a big one in the Aleutian Islands, a 5.0. Here's a 5.0 Japan. This one was on land near Ishiki, Japan, north of Tokyo it looks like. Down here, New Zealand, 4.9, just off the coast of the North Island. Puerto Rico is still getting earthquakes. Here's a 5.3 in Argentina, and so on. Let's look. So here, along this Antarctic plate, we've had quite a few earthquakes, and good sized ones. Here's a 5.1, 5.4, 5.6, 5.4, 5.1. So this is definitely showing plate movement in my mind. Then we've had some Arctic earthquakes of note. And if you look up here, let me zoom out once more. Right up here, there was a 4.8 north of Franz Josef Land. here, okay, now go back in. That was right near the North Pole. Here was a 5.2 north of, in between Svalbard and Greenland. Here was a 4.7 north of Severnaya Zemlya. So the tectonic plate runs right up here across the North Pole. And up here, see, when we go over. And also, I also counted these as Arctic, these big ones here in Kamchatka, Russia, or Okrug, Russia. As part of the Arctic earthquakes. There were 8, all pretty much in one day. The biggest one was a 6.3 that came in on the 9th. So these were pretty much in a 24-hour period. This one came in on the 10th at 4:10 in the morning. So the reporting station is, let's see if I can pronounce this, Chukovsky Autonomny Okrug, Russia. That's my best shot at it. So these are Arctic earthquakes here. And then in the Aleutian Islands, of course, in this 5.0. And look at these that were also in Russia, right on the Bering Strait, just across from Alaska. There were 3 here in Loreno and Lavrentia, Russia, a 3.2, a 2.4, and a 2.0. Now, we don't normally see earthquakes right up here, but it would make sense. We see so many in Alaska, it would make sense that we would see them over in Russia. I think that it's just that they're not reported as much from Russia. And then, looking over here in the US and Canada, we've had a few up here. Here's a recent 3.3 in Canada. Here's some small ones. Here's up in Maine and New York. And here's a 2.3 in Canada. Here's some. Look, these are on the New Madrid fault zone. 11 right there. Missouri and Arkansas. Here are the earthquakes that have happened in Oklahoma, 44 this week. Here's some in Colorado. We normally don't see them there, but we did have some in Colorado. There's 4 at Crested Butte. Newcastle, 1.3, and a 0.8 at Walsenburg. Here are the ones throughout Utah. Here's Yellowstone. Even went up into Canada here, a 2.5. So there's 64 right there, I would say, in the Yellowstone region. And then up here in Washington, quite a few. Here's a 4.4 on this Juan de Fuca plate, just off the coast of Vancouver Island. And then quite a few more down on this fulcrum point of this Juan de Fuca plate, 3.1 and so forth. And here's your Northern California, North Nevada. So when you see them like for a whole week, you can really see where they're clustered up and the patterns. So it's very active, and we can see this event area down in Ridgecrest and Searles Valley is still quite active. Let's see how many they've had this week. And I call this the event area 398 this week in this view. And the orange ones are in the last 24 hours. The red ones just happened, are new. Let's look at Puerto Rico. Here's a big one, a 5.1 at Barracuda, Dominica. That was in the ocean. Hopefully that didn't cause any damage. But right here, this is where they've gotten hit in southern Puerto Rico. 570 earthquakes this week. And they had, there was, I think the largest was like the 6.4 or something. But they've had damage, and it's still rocking. And I think they've had some deaths. 5.6. So I don't know when that's going to stop. It doesn't look like it's slowing down. There's South America. This one is near the Galapagos Islands. Its reporting center is Ecuador, but it's really Galapagos Islands. It's in the ocean, 4.6. Then down here, see, New Zealand has had some. And your Ring of Fire is getting it. There's Japan. Let's look at the Luzon, Philippines. So the area where the volcano is going off we're not seeing large earthquakes. I guess all of those that they talked about were smaller, like we saw. So right there is that volcano. We even had one in Poland today, a 4.2, near Orzesze, Poland, at 5:34 this morning Pacific time. .2 near Sinabang, Indonesia. Now Sinabang is over here. It's a volcano. It's over here on the land. Oh, it's over here. Sorry. So that earthquake was right next to Sinabang. So, there you have it. So I'll go ahead and sign off for now. I hope everyone is preparing their spiritual houses. That's the biggest preparation we need to make, because I do believe we are in the end times. No one knows the day or the hour, so we need to be prepared anytime. Just like the people in Philippines didn't know that that volcano was going to go off, and the people in Puerto Rico didn't know that all those earthquakes were going to be hitting. You know, we don't get warnings. I mean, we do, but a lot of people don't look at the warnings. Sometimes we don't get warnings. So this is why we need to be prepared. I love you guys, and I'm praying for everybody. And if you'd like to support my work, I have a PayPal link below. Or if you'd like to see detailed updates, and when CAMS comes back online, I'll be putting all the methane data up for my Subscribestar members. So I recommend you go on over to my Subscribestar page and get subscribed there so that you can get your email notifications whenever I post. And you know, we can stay in touch, because if anything happens to YouTube, that's the platform where you're going to be able to find me the easiest. Also, my website is margoshealingcorner.com. So until next time, God bless everyone, and go in peace, and I'll talk to you soon. Good night.